Alrighty, so in this video we're going to go over section 3 of exam number 1 in relation to evaluating limits by graphing. So in this case we have function f of x and we have two functions. So we have negative absolute value of x plus 2 plus 3 if x is less than 1. Then we have negative root of x minus 1 if x is greater than 1 in essence. So what do we want to do? So we want to go and evaluate the limits first. So we want to do point A, which is the limit of x approaching to 1 from the left side, because we have that negative sign in the corner of the 1 of f of x. So given that the x is approaching 1 from the left side, we got to use this expression right here, because the condition for it is x got to be less than 1. So x can only be less than 1 if it's approaching from the left side. So we just want to write that. So we do negative absolute value of x plus 2 plus 3 equals just take the 1 from the limit and plug it into the function. So we'd have negative 1 plus 2 plus 3, which just gives you negative 3 plus 3, which is just 0 in that case. And then you have, given that this is absolute value, you got to use the other sign value of the expression. So it's going to be just simply x plus 2 plus 3, which just equals 1 plus 2 plus 3, which is equals 6 in this case. But since the condition for this problem is x got to be less than 1, 6 cannot be it, because 0 is only less than 1 in that case. So the limit of x approaching to 1 from the left side of f of x is going to be 0. And now going on to evaluate the second limit, which is the limit of x approaching to 1 from the right side f of x, we got to use this expression right here, because the condition for it is if x is greater than 1. So in that case, we can just do negative root of x plus 1, which just equals negative root of 1 plus 1, which is just negative minus 1. It's got to be negative root of x minus 1, which equals 1. Negative root of 1 minus 1 is just negative root of 0, which is just 0 in this case. So this limit is equal to 0, just like that. And now we also have another limit that I forgot to write earlier, which is the overall limit of x approaching to 1. So limit x approaching to 1, f of x. So now in this case, you want to take both the left-hand side and the right-hand side and see if they have the same value f of x. So given that they already have the same value f of x, we can determine that this limit does indeed exist, because both the left and the right-hand side match in terms of the f of x value. So we can just say that the limit of x approaching to 1 f of x is just equal to 0 in that case. Now we got to graph those functions. So let's start off with this second function right here. So negative root of x minus 1 if x is greater than 1. So given that x is greater than 1, this function is going to start from over here. It's going to go to the right. So if we take, for instance, if we plug in 1 for x, so if we have negative root of 1 minus 1, which is root of 0, which is just 0. So the value, the point's going to be 1, 0. But since 1 is not defined, this is going to be a removable hole in this case. Not sure if I can make that clearer. Let me rewrite it real quick, just like that. Just draw a big circle. It's going to be a removable hole because 1 is not defined in this case. And now if we take another value, let's say if we take 5, so we do negative root of 5 minus 1, which is negative root of 4. which just gives you -2 in that case. So 5, when x equals 5, y is equal to -2. Now, just draw a line just like that. And you have the function -√(x - 1, like that. And now, looking onto the second expression right over here. So it's got to go this way, since x is going to be less than 1 in this case, so it cannot go to the right, it's got to approach to the left. So looking at the format of the expression, so we have negative absolute value of x plus 2 plus 3. So this value on the inside represents the translation, the left to right translation. So given that it's already positive on the inside is +2, the function is going to shift 2 units to the left. And given that we have the +3 on the outside, the function is going to shift 3 units up. So let's count 3 units up first, just to make this easier on us. So 1, 2, 3, and 2 units up, 1, 2. So it's going to start right here. And let's plug in, I don't know, like some sort of point that could be useful to us. We can just plug in 0, for instance, 0 for x. So if we plug in 0 for x, so 0 plus 2 is 2, and then plus 3 is 5. So in this case, when x equals 0, y equals 5, so it's going to be -5 in this case. So it's going to be something along here. Now we can just like draw the line, just like that. And since this is an absolute value equation or expression, you also gotta make sure to draw it like that as well too, because you're gonna have some sort of a cusp when you have a absolute value expression. So the graph should look something like this. So let me just like write the other expression right over here. Negative absolute value of x plus 2 plus 3. And then lastly, for part D, we have, does f of x have any discontinuity? So yes, f of x does have a discontinuity right here, x equals 1, because there's a removable hole due to the fact that x is not defined at 1. So we can just say yes, f of x has a discontinuity, has a removable hole, let's say, at x equals 1, since it, let me just rewrite this real quick, since it is undefined. So just like that, that should give you the result for this problem. So thank you.